You have fallen into Event Horizon with John Michael Godier. In today's episode, John is joined by Fraser Cain, creator and publisher of Universe Today, one of the world's largest portals of space and astronomy news, with over 140,000 subscribers. In 2006, Fraser joined with Dr. Pamela Gay to create Astronomy Cast, which is among the top-rated and most popular podcasts in the natural sciences. Remember to subscribe to Event Horizon so you never miss an episode.
Fraser Cain, welcome back to the program.
Glad to be back.
Fraser, it was a good year for space, 2023, and we got another good year coming with 2024. So what was your favorite development in space science for 2023?
You're going to love this. It was cat videos from space. I take it for the pause. You have no idea what I'm talking about. So the NASA's Psyche mission is on its way to go to a metal asteroid, which is just the coolest thing ever. And that's going to keep us really entertained. But as part of the mission, they are testing out a tight beam laser communication system. And so when the spacecraft was tens of millions of kilometers away from Earth, they pointed back at our planet and they transmitted a cat video at hundreds of megabits per second, which is so much faster. When you think about the New Horizons mission, it was transmitting in just a couple of bits per second. And it took 18 months to transmit all of the data that was picked up from New Horizons when it passed by Pluto. It's a couple of days of images. It took 18 months to get all that data back home. But Psyche is demonstrating that they have a new way to transmit data in space, which is via laser. And they picked up the transmission from Psyche with a telescope. And they were able to decode this super high def video at incredible speed. And if this is, with that demonstration, you're going to see some version of this technology be installed on almost every future mission from this point forward. And a lot of the missions that are just great ideas are held up because there's too much data that needs to be transferred home. And if this continues to be really successful and we see more tests when it's out at Psyche, then we could see a complete new revolution in the way data is transmitted across the solar system to NASA and other space agencies. So it's a really game-changing technology that is going to enable so much of the kinds of missions that I'm really excited about in the future.
Yeah, it's a huge leap forward. And with Psyche in particular, that mission is going to something that we've sort of seen, but we've never really seen. And that is this intermix of metal and rock. Now we see this in meteorites with like pallasites and mesositerites and all that. And actually I'm getting ready to buy one. There was a pallasite found in Kenya that I'm interested in. But the thing is that those meteorites are weird. That olivine crystals and that just extreme differentiation between iron and stone. And we don't really know what sort of planetary body, what are the conditions of that forming at the sort of boundary between the iron core of an object and the silicate core. And you wonder, does Earth's mantle somehow resemble a pallasite? So you just don't know.
Anything, right? Like all we know is the density. We know the size and the mass of the asteroid, and that gives you the density. And the density is very rocky, bordering on metallic. And so it could be the exposed core of some planetesimal that went through some heavy bombardment, and it's just this chunk of metal in space. And yet, because it was large enough, it probably had volcanoes, but the volcanoes would have been metal. And so there could be like metal volcanoes on the surface of Psyche. And so, and your imagination just runs wild with what could still be happening on this world. Or it could look very much just like a regular old asteroid. It's going to look dirty and like asphalt. And yet we know that it's got that density. And so when the spacecraft gets there, it can orbit around it. It can start to make really detailed gravitational mapping of this asteroid and tell us so much about it. But I'm like rocky meteorites are fine, but they just feel like a rock. Metal meteorites are special. They feel like a piece of alien space metal, like absolutely. That you're holding on to this thing that looks like an asteroid or like a meteorite, but it is strangely heavy, and they are just wondrous. Like, I'm glad you're buying one. I've got a bunch of meteorites, and they're not that expensive, for tens of dollars, low hundreds of dollars for something a little more substantial. You can go out and buy a piece of space metal, and I guarantee it will give you superpowers.
I do not have superpowers from my meteorite collection.
Yeah, I mean, you might. I mean, the superpowers are all really mundane. Like one of my friends who I gave a meteorite to, he found that after he got it, he didn't have bad weather when he went on motorcycle trips.
Well, that's useful.
Yeah, totally. So I think those are the kinds of low-grade superpowers that you can expect when you own your own meteorite. So if you're in any way fascinated by this, get a meteorite.
Yes, I may possibly have become better at boiling eggs as a result of a meteorite.
That sounds really legit to me.
Yes, it's true. Now, interestingly, when we talk about that, the idea that meteorites are weird, one of the weirdest aspects of iron meteorites is the Widmanstätten pattern, where you can etch it with nitric acid and actually see the crystalline structure of this meteorite that probably was the result of it cooling and crystallizing out into different sort of alloys of iron and nickel. And there's just nothing like that on Earth.
Yeah. I was recently in Tucson, and they have a gem and mineral exhibit in downtown Tucson, but it is really space-based because, of course, they've got the Lunar Planetary Lab at the University of Arizona. I always get these. I have to be careful. And it's amazing. I mean, they've got OSIRIS-REx exhibit, and they've got a whole wall of just meteorites. They had the largest moon rock that I've ever seen. And a lot of those like pallasites, ones that are sliced down and then etched, and you see just this amazing crystalline pattern. Yeah, it is a rabbit hole of a hobby to get into, collecting meteorites. Like, I just have the one big one, but I want more.
There's a subset of that I actually got involved with when I was a teenager. So there are two impact structures in my state, very ancient ones, and I would go down and collect shatter cones, which are a geologic feature caused by a meteorite impact, an asteroid impact. And I actually would go down there and hunt them. I still have some. Look at weird geologic features that are related to meteorites, in addition to actually metal detecting for them, which I never really found any. But I did find geologic shatter cones that are linked to impacts. And I always found that fascinating that, an impact 15 million years ago is still evident. On Earth, and you can go out and try and find samples, even if the meteorite is gone.
And another version of this hobby that I think is really fascinating is looking for micrometeorites. And so if you've got a steel roof and it's collecting debris, you can take that debris and then you can put it in a bucket, separate it out, run a magnet through the debris, and you pull out all of these little spherules from your roof, from your gutter, and then you can examine them under a microscope. And most of them are industrial pollutants. So they make these little, coal ash, things like that. They make these little spheres, but some fraction of them, 1 in 100, whatever, are clearly extraterrestrial. And you can tell that they are pieces of space metal that fell onto your roof. And you imagine how many of those are on your roof that are the rock kind that you just can't pick up with the magnet. So there's a great. I did an interview with somebody who does this. There's some books you can look into. And so if you want to go meteor hunting, but you don't want to leave your house, you can still do this.
One's lawn is full of meteorite material, and we never even knew it.
I know. Yeah, you have no idea how much you're surrounded. 100 tons of space dust falls onto the Earth every day and just rains down across the entire planet.
And you can see it. You go out in a meteor shower. Well, something may make it that something tangible may make it to the ground from an annual meteor shower. And I mean, you'd never know it, but
Yeah.
it's sort of, interesting to think of the interaction between Earth and space in that way.
Yeah.
Which is another thing that interests me, is that when space comes down to you is the coolest thing. And that's behind the meteorites, it's behind everything. And also the solar eclipses, the totality of a solar eclipse, which I've got one coming this year. That's going to be,
we share it.
We do, don't we?
Yeah, so we actually share this eclipse. So the eclipse is going to start in Mexico. It's going to pass through the US, into Canada, and then poke out the top of Canada. So I'm probably going to go to Texas because that gives me the best shot at being able to actually see the eclipse, because Canadian weather in April isn't super duper. But yeah, it's another opportunity to see an eclipse.
I actually got eclipse fever from the 2017 eclipse, which again passed over my house. I was right in totality.
Yeah.
I was just not expecting that, what I saw with the solar corona stretching out like that and just following magnetic field lines and seeing,
it's otherworldly. Yeah. I mean, there are these things that you can do, and eclipses are one of them. If I was at a place with a 99% eclipse, and you told me that there was a 99% eclipse, I might not turn around and look at it. It's not that interesting to me. A partial solar eclipse, things get a little dimmer. It's fine. You get a chomp out of the sun. It's fine. But a total solar eclipse is otherworldly. It is like you get this sunset that happens in all the horizons. The sun is completely blocked by the moon, and you get that corona effect around it. And there's a crowd of people that follow the eclipses, like the Grateful Dead. Like, once they see one, they can't get it out of their head, and they want to experience that feeling again. And I totally get that. The other one is an aurora. Like, if you've never seen a bright aurora, you really have to get one into your eyeballs, because it is, again, just otherworldly. You can't believe what you're seeing. And no pictures can really show you. A video doesn't really capture it. You have to see it with your own eyes. So there are these things that are relatively easy to chase down. The one that I always add to that is going and seeing a rocket launch, because it is like to just watch this controlled explosion in your vicinity go off. It is a sight to behold. And again, it's fairly easy to do. You go to Cocoa Beach in Florida, sit on your deck drinking your Mai Tai, and you watch a rocket take off. It's nice.
It really is. And that's still the joy of astronomy, is things like that. And with the solar eclipses, it is like the solar system that we study so in depth comes down to us, becomes real and tangible. It's not just some shining light in the sky like Jupiter or something like that. This is much different than that.
But even that, like setting up a big telescope, standing on the street corner, pointing it at Saturn, and inviting people to come and take a look through it, and just being present for their first time ever seeing Saturn through a telescope is just wonderful.
That's what hooked me originally when I was.
I know you've done a ton of sidewalk astronomy, and that is just there's nothing like it.
And it's satisfying, because Saturn is Saturn. You're like, well, I might not see much when looking through a telescope, and then all of a sudden there it is with its rings, and it's right there.
Yeah. People are like, I can't believe this is real. Like, is this real?
And also, another one that did it for me when I was a teenager was the fact that I could see Jupiter's bands, 2 of them.
Yes.
And there they were.
And the moons.
And then luckily back in those days, Comet Schumacher-Levy 9 hit Jupiter, and you could see it through the telescope. You could see the scars in the atmosphere.
Yeah.
And
I didn't try to visually observe that.
I did. I was using an 8-inch, I still have it, an 8-inch Dobsonian, and I was able to see, you could see it. You could see the dark scars as it rotated around, because it hit on the far side of Jupiter. But as it rotated around, they were visible, and I was able to see them with that 8-inch telescope. I don't know what the magnification was, probably pretty high, but yeah, definitely, it was definitely a unusual thing to see.
Yeah,
and I love that idea though, that again, we can be tempted to look at the night sky and say that's basically unchanging over my lifetime, but not really. Sometimes, sometimes it gets really dynamic. And the another thing that, and we've talked about this before, that I'm waiting for is a great comet, something really crazy,
Yes.
like they used to describe.
Yeah. The kids these days have no idea what a great comet really looks like. Like, we saw Hale-Bopp and Hyakutake, but it was like 2000, 1999, like
97, I think, for Hale-Bopp, wasn't it?
97. Like, we're 25 years. Like, there are people who are going to be listening to this who were not born when the last great comet was here, and it was stunning. Like, you went outside, and the tail was the size of your hand across the sky. Hold your hand out, and the tail stretched all the way back, and it had multiple colors. You could see the main tail, and then the ion tail, and this was even before all this modern astrophotography techniques came out. And so every picture of a comet that's been taken in the last 20 years is fine, but it's with a bad subject. It's going to be the good comet. And then people talk about even the bigger ones back in the 60s and stuff. Yeah. And then, of course, a meteor storm is another thing. Like, we keep getting these hints and threats of a meteor storm, like one where it's hundreds of thousands of meteors per hour. And that happened like 1966.
Yeah.
Again, that would be stunning.
Yeah, the Great Meteor Storm, which was a particularly dense part, as I recall, of a regular meteor shower that happens every year. It's just you go through a dense part every so often.
Yeah.
And it just lights up.
Yeah.
I don't know that's really hard to predict, though.
It is hard. So each time a comet, like all the meteor showers come from comets. One comes from an asteroid, but they mostly come from comets. And so each time the comet moves around the solar system, it leaves a trail of particles, and the Earth will pass through the trail, but it'll pass through some older version of the trail. But every now and then you get the Earth passing through a very recent version of the trail that's been laid down, and that gets you the meteor storm. And you get one every 100 years or so, and they just sound off the charts. And I mean, the closest I've seen was the Leonids back in, again, like 2000, 2001. Maybe we talked about this before, but I was watching a meteor every few seconds, which was great, but we know the universe can do better.
Indeed. I wonder if we could create, and this is my usual crazy talk, if we could create an artificial meteor storm.
Yes. No, this is in the works. So there's a Japanese company that has developed an artificial meteor shower from a satellite. And so it'll eject a meteor shower. I don't know if it's been launched yet, but the plan was to test it. And obviously, like, I think people are kind of grumpy about the idea because it's more light pollution, but I'm okay with it because it's in a very small localized area. It's a one-time event. It's not like an ongoing, really bright satellite that's going to be up there all the time. Like, you're going to release the particles over Tokyo and see the meteor storm. So it's been proposed, and I think someone is fairly long down the pathway of actually developing it.
It's an interesting idea, but what are your views on the growing problem of orbital sky glow? In other words, Starlink and satellites like that creating issues for astronomers versus, which I think this is much worse because I've seen it firsthand happening, is sky glow from the cities, the growing sky glow.
Yes.
I honestly am more worried about streetlights than I am satellites, because you can come up with algorithms and stuff to filter that out and paint them black or something like that. But the sky glow, it's just done nothing but get worse here over the course of my life.
Yeah, and I mentioned I spent a month in Tucson, and it was quite amazing to be in a city that takes sky glow very seriously. Like, we were a little outside of the city, and I could see the Milky Way from the backyard of the house we were staying at, when normally in any other city it would just be overwhelming with sky glow. So they take it really seriously there, and there are things that they can do to bring down the sky glow and bring the night sky back into people's lives, which I think is really important. Like, so much of humanity has no access to the Milky Way, to the fainter stars, to just be able to go outside and take it in. We're mad about light pollution from satellites. You should be enraged by the light pollution that has already stolen the night sky from most of humanity. And that and it doesn't have to be this way. That there are relatively simple technologies you can use to point your lights at the ground, to use various shades, and still get the brightness that you require without ruining the night sky. And it's not just people. I mean, animals are suffering from this. There's all kinds of downsides to having a bright night sky, and it doesn't have to be this way.
Well, it also wastes energy, because if your light is going upward, it's not doing you any good. You know?
Yeah. Well, and this was one of the questions that people had, that as these new low power LED lights come online, will the amount of energy that's being used to light outdoors go down? And the answer was no. That all it did was it just made outside brighter, because they had they used the same amount of power, or sometimes even more, and they were able to just make outside even brighter.
Yeah, it's disconcerting, and I do miss it, because I remember back in the 1980s in this area, which is now urban, but back then not so much, that you could actually see the Milky Way at night. And now, no. The only thing I can see at night without my telescopes is just planets and a couple of stars, Sirius, things like that, Orion, but no Milky Way any longer. And then even through the telescope, the night sky is bright. It isn't black anymore. It's lit up, and there's just no way around it. And I mean, how far are we going to go with it?
All the way.
No night sky at all.
No, just take it all away.
Now, Fraser, there is a mission that is of great interest to me, as they all are, I guess. But there's one that I don't think gets enough press, and it's the Parker Solar Probe.
Mm-hmm. Well, it's hard to keep track of the Parker Solar Probe. I mean, it was launched several years ago, and its job is to study the sun closer than any other spacecraft would. And it has been performing a series of gravitational slingshot maneuvers using Venus and Mercury to get closer and closer to the sun. And every 6 months or so, we get another press release from NASA saying that Parker Solar Probe has made its closest flyby to the sun, and now it's vastly closer than any spacecraft has ever been, and is still going to be getting closer. And the design of the Parker Solar Probe is really ingenious, because at its closest point, it is so hot that it's starting to cause damage to the spacecraft. And so they have it on this elliptical orbit where it flies out from the sun, cools down, gets its affairs in order, and then comes back in, gets blisteringly close to the sun, and then flies back out. Let me just check to see what the latest Parker Solar Probe distance was, because it's kind of stunning. Get the actual specific. So the last big one we had was in August, and they came within they did a flyby of Venus in August, and the closest approach, the perihelion, they came within 7.3 million kilometers, and it was moving almost 400,000 miles per hour, which is the fastest any spacecraft has ever moved. Any spacecraft humanity has ever made.
I would not want to be that close to the sun. The sun is scary. I mean, it's a star.
Yeah. Yeah. So the last one, it did its 16th close approach on June 27th, and came within 5.3 million miles, and it's just going to keep getting closer and closer. I'm trying to get the actual from NASA, their final. You can just edit this, right? I noticed that. It's weird. I wonder why. I'm not. Do you want me to?
Now, Fraser, the elephant in the room regarding spacecraft is the profound success of the James Webb Space Telescope. In my 35 plus years of being interested in space, I've never seen anything quite so successful. What are your views? How do you feel about the JWST?
Yeah, it has been phenomenal. And I think like this was, described as the elephant in the room. I mean, for the longest time, it was the monster that ate astronomy budgets. It cost $10 billion. It was a decade late, and other interesting projects got canceled because of the budget overruns, the time overruns on JWST. And yet it did launch. It launched now 2 years ago, more than 2 years, 3 years ago. Now I lost track of time because it was Christmas Day.
Was it
3 years ago? Anyway, I've lost, we've done a whole year, 2 years, maybe 2 years ago, 2 years ago. Anyway, and as you say, its impact on astronomy has been profound. On the cosmology side, that conversation is still unfolding. And I think we got that sort of initial run of results when people were still learning how to use JWST. We got these, we've seen the farthest galaxy that we've ever seen. Galaxies are bigger than anyone expected. We may have to rewrite our understanding of cosmology. And that has settled down. Like, people have gotten a lot better at being able to both take the images with JWST, but also do the spectra analysis, which has been able to get a much more accurate idea of the redshift of these galaxies, figure out where they are in time, understand what they're made of, and things are moving back into the established models. And so I think cosmology has not been overturned in the way that some people were really hoping that it would be, that in fact the missing puzzle pieces are being found nicely and things are being slotted in, and yet we're learning a tremendous amount about the early universe, about the concentrations of gas. I mean, the results just keep coming out, that larger supermassive black holes are being found, that the results of some of the first, perhaps the chemicals that came from the first stars in the universe are being found seeding into nebulae and in stars that are forming in galaxies, that we're seeing structures, tidal tails, tidal interactions, building blocks of galaxies coming together, spiral galaxies seen in earlier than anyone expected. Like, there's a lot of really interesting things that are being found. But I think the more profound impact has been on exoplanets, that Webb was a better exoplanet hunter, or I guess studier, than analyzer, than anyone had really let us know. And so while the cosmological discoveries are great and newly forming stars is really interesting, it has just been so good at studying the atmospheres of exoplanets in a way that there was no tool ever that was this good. And so we had a few hints of exoplanetary atmospheres with Spitzer and Herschel and other infrared telescopes, but Webb is just producing these beautiful spectra of the exoplanet atmospheres, showing the presence of methane and water vapor and oxygen and carbon dioxide and all of these chemicals, sulfur dioxide, all these chemicals, in a way that it's just unambiguous that these things are there. And I think the exoplanet community has been so excited by the results. A lot of the interviews that I've been doing recently have been with people in this community, and they're just so stoked about what they're finding.
And just to remind everybody, check out Fraser's channel and also Universe Today, his website, which is an excellent news source.
Yeah. Like, if you go back and look at the recent interviews on my YouTube channel, it's just this. Because I'm really fascinated by studying exoplanetary atmospheres. Obviously, because this is how we find life, right? And so that's been great.
And we also, that's a two-sided coin. Lack of atmosphere, like for example at the TRAPPIST-1 system, where we're not really sure what red dwarfs do to their planets and how they flare and what are the intricacies of it. But then we look there and we detect no atmosphere on the very closest in worlds.
Yeah, that story is unfolding now, and the outcome seems bad. That I think we're getting the sad ending to this story. All after NASA's Kepler spacecraft lost its reaction wheels and they had to shift the mission, they were able to observe these M dwarfs, these red dwarf stars, and they were able to find planets around these stars, Earth-sized planets in the habitable zone. And of course, famously, we know of the TRAPPIST-1 system. And so this is the hope, right? That maybe we weren't able to find the Earth-like worlds orbiting around sun-like stars, but maybe we're going to find these Earth-like worlds around red dwarf stars. They have a habitable zone, but these stars are also awful. They have flares that are much more powerful than a star of that you would expect of that size. The planets, because the star is giving off less radiation, the planets are huddled up close, and so they're just taking enormous solar flares, broadsides, just one after the other. And the worry is that these planets, even though they might be in the habitable zone, they are just too scorched by their star to be habitable. And we saw, thanks to Webb, we got analysis of the first two planets in the TRAPPIST-1 system, B and C. And the hope was that maybe these are going to be super Venuses. And nope, they're airless. So they're super Mercuries. And then maybe the hope is TRAPPIST-1D, which is the first planet that's going to be, in the habitable zone. TRAPPIST-1D, E, and F. Those three worlds are in the habitable zone around this star. And we haven't seen the official results, but I talked to a researcher in a recent interview, and he's not particularly enthusiastic about the results. And he sort of feels like the writing is on the wall now that red dwarf stars kill their planets. And so we might have to throw out that entire class of planets as being just too awful and move on to the larger stars with less, where the planets are farther away in the habitable zone and the stars produce less deadly flares.
There's still hope, though, and unfortunately, this is a far hope because we can't detect this. But that some of those planets in a red dwarf systems might have ice shell moons and may host a sort of that secondary habitability that's protected from the radiation of the star. But the thing is you can't detect it. It's locked under ice.
Right. I mean, once you've got things under ice, then you're protected from the radiation. You don't have to worry about the atmosphere. But then I don't think yes, there could be life on Enceladus or Europa, but that's not what we're imagining when we're thinking about a world filled with life. We're imagining some forest moon, right, of Endor, not a ocean with space whales under 100 kilometers of ice.
Now, there is hope, though, because if the red dwarfs are problematic and unlikely to host surface exoplanet life, Earth-like life, you still have another entire class. In addition to Type G, you also have Type K, the orange dwarfs. And my understanding is that these are really difficult to study exoplanets and characterize their atmospheres around the orange dwarfs because of glare. Have you heard anything about that?
Right. So this is the great challenge, and it's not just the K dwarves. It's the G dwarves. It's the stars like our sun that the brightness of the star is so overwhelming compared to the brightness of the planet. It's a factor of 10 billion. So in other words, you've got to be able to dim the star by a factor of 10 billion to get at the light from the planet. If there was no star, and yet the star was illuminating the planet somehow, then we could see it with the kinds of telescopes that are available today. James Webb could see this, but the star is overwhelming. And so James Webb is equipped with a coronagraph that is able to dim the light of the star, and it's pretty good. The Nancy Grace Roman telescope, which is the next big space telescope that NASA is working on, is got, its main job is to characterize dark matter, dark energy, to map out the cosmos, but it also has a next generation coronagraph on board that theoretically should be able to dim the light of the star by a factor of 100 million. And that should be enough to dim the light from a star to be able to reveal Jupiter-type worlds orbiting around a sun-like star. And so if this works, this technology, and it's a fascinating, a lot of people aren't aware of this. And you sort of sacrifice the entire telescope field of view to zoom in on this tiny little region of space and run it through this coronagraph to get this difference of light. But Nancy Grace Roman should be turning up exo-Jupiters. And if that works, if this technology is shown to be effective, then the plan is to then scale this to the next level with the Habitable Worlds Observatory. And that's going to be what was, we had LUVOIR and HabEx, and there was all these big mega telescopes that were going to be coming after James Webb. And now they've been collapsed down into this Habitable Worlds Observatory. So if Nancy Grace Roman's coronagraph does its job, then we should get a chance to see the next iteration of that coronagraph, and then we will finally be observing Earth-sized worlds orbiting around K-dwarfs and sun-like stars.
Very weird history, the Nancy Grace Roman telescope.
Yeah.
In that it started out, at least its mirrors started out, intended for a spy satellite. What's the history of that, and what's the timeline on getting that up and running?
I mean, that's always such a bizarre story. So I guess, the U.S., people always say, like, oh, why don't they point the Hubble Space Telescope at the ground? Like, they could use it as a spy satellite. And you're like, well, let me tell you a story, which is that back in the early 2000s, the military contacted NASA and said, we've got these 2 Hubble-class telescopes that we don't need, that aren't good enough anymore for the kind of Earth observation that we do, the kind of spying that we like to do, that these 2 Hubbles, 2 were not good enough. And so said, do you want them? And NASA was like, of course. And so they built one into one telescope. I forget which one it is, IPXC? Anyway, they built one into a telescope, and then the second one is the Nancy Grace Roman. And so they changed the optics on it so that it's got this really big wide field of view. And it's due to launch 2027? Yeah, 2027. And so the Nancy Grace Roman telescope is due for launch in 2027. And, it's the next big space telescope that I'm quite excited about. And I think people aren't really aware of what it's going to be capable of. It will find hundreds of thousands of exoplanets, probably tens of thousands for sure, using gravitational microlensing. It will also be able to identify these exoplanets directly imaging, and so using that coronagraph that I mentioned, not to mention characterizing dark matter, dark energy, helping map the cosmos at a scale that's never been done before. So it is a really exciting telescope.
Now, it's a visible light telescope, right? It's not infrared.
It's infrared. It's infrared. Yeah, but not infrared in the same. Yeah, it's near infrared, so it's not in the same class as.
Well, that's interesting. That actually makes
James
sense
Webb,
for spy satellite. The next mission that we'll cover is a lot more complicated. Starship, delays, and all sorts of things going on. What is been the progress for 2023 regarding Starship, and what does 2024 look like?
This is so hard because there are these entrenched groups who are ready for a flame war. And so as long as I piss off everybody equally, I think I will have done my job. So in early 2023, April, we got that first launch of the Starship Super Heavy stack, and it destroyed its launch pad, and the thing came apart pretty quickly after launch and then was detonated. And they didn't meet any of their objectives, right? Like their objective, I guess they got off the pad. You could see right from the beginning of the launch that several of the engines weren't working, and it just kind of got worse from there. The launch that they did just a couple of months ago, anyway, the launch they did more recently, late November, was much more successful. They had completely rebuilt how the pad works. So they had what they call a flame diverter, a big steel plate that was underneath the launch pad, which diverted the flames, prevented the fire tornado that caused all of the damage from last time, and it was able to get off the pad. As you could see it lifting off the pad, you could see all of the engines were burning nicely, and it did its separation, and then it exploded. So the one addition that they added to it this time was that they're going to do something called hot staging, where originally the way Starship was going to work was that the Super Heavy would sort of slow down and it would sort of split itself apart, and then Starship would ignite its engines and continue the journey up to space. And that was too difficult to control, and so they shifted to something called hot staging, which has been done before, but it meant that Starship fired its engine while it was still attached to Super Heavy, and then it was able to detach and then continue the flight. And so we got that hot staging, and that worked perfectly. And then Super Heavy was supposed to do a like sort of flip over, do a burn back, and it didn't seem like it was able to reignite its engines, and then it exploded. And then Starship, and this is the one that's more kind of confusing because we still haven't got like an official breakdown of exactly what happened with Starship, but it continued on sort of beyond what we could see, and then we heard that there was a loss of signal, and people were sort of downrange, were able to track, and it looked like the thing came apart, some cause that made it break apart, and so it wasn't able to complete its half of the journey either. So in theory, the next version of it is now being prepared for launch, and because the launch pad wasn't destroyed, these other rockets were ready to go. We should see a launch within a couple of months, the next test. And hopefully this is the one that'll sort of meet all of the objectives that they had. The Super Heavy will launch off the pad, you've got the hot stage separation from Starship. Super Heavy will flip itself over, do a burn back, land softly in the ocean, and then Starship will continue on, do some kind of suborbital flight, and then do its own soft landing, re-enter, do a soft landing off the coast of Hawaii, and we should get sort of a completion of the mission. But SpaceX also has a habit of skipping steps. So if they feel like they've learned enough from that first launch, I wouldn't be surprised to see them do something more complicated, like do a full orbital launch. There's like a rumor that they might also be attempting to do a practical test of a cryogenic propulsion pumping. So one of the requirements that NASA has for SpaceX to demonstrate the Starship can pump cryogenic fuel in space. And so because the future human landing system version of Starship will need to transfer like 15 launches to transfer all of the cryogenic propellant to the version that's going to go off to the moon. And so they need to start demonstrating that they've got this skill down. And so one theory is that they're going to put a pumping system inside Starship, and then once it's up in space, try to transfer propellant from one tank to another to demonstrate that they can do this space-based cryogenic transfer. And this is becoming a problem because the Artemis 3 mission, which is in all other ways moving forward, like the rockets are almost built, the plan was to launch this at the end of 2024. It's been shifted now to the end of 2025. This isn't long, and it's heavily reliant on the SpaceX Starship as being the landing system. And so between now and the end of 2025, let's be honest, let's be serious. It's going to be 26, maybe it's going to be 27. But Starship has to launch successfully, has to be able to fly one of these tankers to space, has to be able to transfer propellant, has to do 15 to 20 additional launches of Starship, transferring propellant to a tanker, and then the tanker has to transfer the propellant to the human landing system. The human landing system has to go to the moon, has to test land on the moon and fly back to space, and this all has to be done before Artemis 3 is ready to launch. That's a tall order of steps that SpaceX is going to need to do, and they're really now in the middle of the critical path. And so if they have more delays, then we're going to start to see all of Artemis 3 start to slip based on that.
At least we have yet another rocket system that is now on the menu, or coming on the menu, and it is ULA. ULA has developed the Vulcan rocket, and that is a replacement for Delta and its Atlas, its previous rockets, which were venerable, to say the least.
Yeah.
But now they have a new one. What does the Vulcan rocket system offer us?
So the Vulcan is United Launch Alliance's response to the Falcon system. And we're at this point where it's kind of ridiculous because the Falcon 9 rocket launches all the time. SpaceX almost hit 100 launches in 2023. They've been launching the regular Falcons. They've been launching the Falcon Heavies. Like just a couple of days ago, a Falcon Heavy rocket just launched the X-37B into space. And who knows what that does. But anyway, and both side boosters landed successfully. Like these things work great. And so the Vulcan is United Launch Alliance's response where they're going to try to create or provide more reusability in their rocket system. And so the main part of the booster, the big fuel tank, that will still be disposed, but in the beginning, the engines will be reused. And the plan is to like have the engines fall off the bottom of the rocket and then be collected by helicopter. And then over time, they will develop more and more reusability of this rocket, hopefully getting to a point where they're starting to match what the Falcon is capable of. And have yet to test that first Vulcan rocket. It should happen this year. Yeah, so like we could just be a couple of days away from the first launch of the Vulcan rocket. Who knows how much of it will actually be reused? Like this is just a first test flight to show that the system even does its job. And then we will see, hopefully, more and more reusability over time. But it seems kind of crazy compared to how far along the process SpaceX is with Starship, which is a fully reusable 2-stage rocket, compared to Vulcan, which is going to be a partially reusable booster and then a disposable upper stage. And so I think it seems kind of bizarre in this modern age to not be building fully reusable boosters like what Rocket Lab is planning to do, like what Blue Origin is planning to do. The Chinese are doing this. Like this is the way. SpaceX has demonstrated that you reuse that booster. And so hopefully ULA will be able to get the kinds of savings and be competitive. Because I don't want SpaceX to just run away with the whole market. I want there to be competitors. I want there to be a vibrant launch market. But we'll find out if they'll be able to do it.
Now, what of Blue Origin? Where are they at? And we've been waiting and waiting, you know?
Yeah. So there was the last launch of the Blue Origin New Shepard back about over a year ago. And then there were some anomalies in the flight, and so they took a break while they were testing to figure out what happened. And they finally did a new flight of New Shepard just a couple of weeks ago. And that is, of course, the suborbital flight where they fly up to the edge of space and then detach the capsule. Capsule returns by parachute, and they do a bunch of science experiments. And it's vastly less energy than going full orbit. But Blue Origin has been working on their New Glenn rocket, which has a reusable first stage, but it's bigger, but like Starship. Sorry, as a reusable first stage, like Falcon 9, and then a disposable upper stage. And this is going to be their response, their heavy lift response. And they've got lots of contracts, but we just haven't seen tests of this rocket. It just keeps drifting and getting pushed back. And now we're at the point where the hope is that they're going to do a test. The rumor is they'll do a test in 2024, but who knows at this point.
They do seem to have had some success in selling engines, though, because, well,
yes.
I think Vulcan actually operates on a Blue Origin engine, right?
Yes, yeah. So Vulcan is using their BE4 engines, which are, a Methalox engine. And so they've demonstrated these engines work. And, the engines are a really hard part of making the rocket go. And so the fact that they've got they're supplying these engines to another company shows that they're able to make these work. So it's getting the whole system together. I mean, we've seen what the fairing looks like. We've seen plenty of artistic illustrations of what this rocket is supposed to look like, but we have not seen the kinds of tests that you see as a rocket is being prepared. Like when you think about, even with the Space Launch System, you saw hot fire tests, you saw various full wet dress rehearsals of different parts of the rocket. Like there is a there are all of these signals that you see before a rocket is finally launched. And SpaceX is doing this all the time. I mean, they are rolling these boosters out. They are clamping them down. They are firing them for long durations, demonstrating that the engines work for the kind of time frame that you need. We haven't seen any of these tests with New Glenn. So it would be amazing if New Glenn launches this year, because again, we want a vibrant space agency. We want a market that has competitors who are trying to one-up each other in terms of service and quality and price and all that, as opposed to just one supplier that's running away with the whole thing. Like, that's how you get monopolies. You don't want them. So hopefully we will see a New Glenn flight this year. I mean, I think the thing to really keep an eye on actually is China, because China is just moving really relentlessly forward in all of their plans, with both in terms of human spaceflight, in terms of their robotic spaceflight, in terms of developing new crew capsules, lunar landers, and a new heavy lift rocket. Their plan is to land humans on the moon before 2030, 2029, and I think they're going to do it. Like,
very likely.
Yeah. I mean, they've got all the pieces in place. They've redesigned their crew capsule. They've got a lunar lander design. They've got a new heavy lift rocket that's in development. And their plan is really simple. They're going to have two of these heavy lift rockets. One's going to carry the lunar lander. One's going to carry the crew capsule. They're going to meet up at the moon. The crew is going to go from the crew capsule into the lunar lander, go down to the lunar surface, and use the exact same technology from their recent sample return mission. Like you can see all the pieces coming to place, right? They tested this technology. There's another lunar sample return mission coming in next year to further make sure that this is right. And then there's like another one that's going to be a couple of years later. So you're going to have two more cracks at doing sample return, as well as a sample return mission from an asteroid. So they're really starting to dial in getting payloads off the surface of the moon and back into space, and then bringing them back to Earth. They've demonstrated their ability to send humans to and from the Chinese space station. And so that idea of having two identical rockets with two roughly identical payloads that meet at the moon is really simple compared to what is going to happen with Artemis 3. And so I would not be surprised if they just meet their schedule and blow right through it, right?
Very pragmatic is my assessment of that. They don't get caught up in all of the politics and bureaucracy that creates mission profiles in NASA and ESA for that matter. But I mean, they just go and do it.
Yeah, I mean, there's, like, for all the downsides that you get from all of the other aspects, boy, you can get a well-run, or at least a space exploration plan that follows a long-term objective, because, people don't have a lot of choice. You end up with the same party every year, and they just follow the plan. So, yeah.
Now, has China released any information on where on the moon they're choosing to land?
Yes. I mean, they're aiming for the South Pole as well.
I see. But
I wonder, this is just outside of my brain, but we did cover this on Universe Today. So they put out a paper. China put out a paper in 2022 where they were proposing sites for a lunar research station. And that would be obviously the same place that they would send humans. So it's going to be at the South Pole, close to the Atkin Basin.
So essentially the lunar missions that are being planned are look for the ice at the poles and see what can be done there, and that's the area of interest. And it's not so much the going to the lunar mare or anything like that. My question is that more dangerous? In other words, going into terrain that's not completely flat like that seems to up the danger level, doesn't it?
I don't know. I mean, at the end of the day, the moon is cold and then it's hot. You don't have a lot of atmosphere. Like, the conditions are roughly the same, but as you said, there are mountains and craters and stuff. The lunar landing sites that were chosen for the Apollo missions were like really right there in the middle of the moon, that they were easily seen from Earth. You could transmit to and fro from the moon. The challenge of landing at the south pole of the moon is about being able to communicate, because in some cases you're not going to have a direct view of Earth. And so you're going to have to use some kind of relay transmission to be able to do that. And again, the Chinese have demonstrated this. They landed a rover at the South Pole. They used a relay satellite on the far side of the moon to communicate back to Earth. And they were able to demonstrate that this is feasible. And so that is one of the big challenges. And NASA is considering how they're going to be solving the same problem as well. So anyone who's going to the South Pole of the moon has got to think about how they're going to get their data home, how they're going to maintain contact with the astronauts.
Now, another area of interest with what China's doing in science is FAST, which is now the world's largest radio telescope, and nothing really compares to it ever since Arecibo collapsed. So what is on the agenda for radio astronomy with FAST?
Well, FAST, as you said, is a gigantic telescope, 500-meter telescope. It was bigger than Arecibo. It didn't have the same radar capability of Arecibo, and so like Arecibo really was a unique instrument. FAST is bigger, but it couldn't do the same things that Arecibo could do. But you know, we're seeing a lot of research coming out of China for their work on pulsars, on doing a lot of radio astronomy observations. And one of the really interesting things, actually, there's just a paper that just came out today that I was looking at. They're putting a big investment into SETI. So while in the West, interest in SETI is finally there, like NASA is finally funding SETI papers, doing, you know, researches and things like that. The poor people at SETI have needed to use borrowed data, having to set up pipelines so that they can slurp up some of the data that while someone's like examining pulsars. But again, in China, they are taking this very seriously. There is both local funding for SETI searches as well as international collaborations using FAST. And they have been studying known exoplanets. They've been studying globular clusters, where you could theoretically have like a bunch of civilizations inside a cluster, because there could be 1 million stars in there. And so you could sort of scoop up the whole cluster in one go. And they've been looking for signals from extraterrestrial intelligences. So that's one of the big things that is quite exciting, is there's a lot of really interesting SETI work that's coming out of China as well. I wonder if it's like inspired by the three-body problem, like because that book has been so successful that there's a lot of support in China to sort of, I don't know, live up to the expectations of the book.
That might be what's going on, because, you know, sometimes literary and cultural things can actually affect policy.
Yeah, you think about like the effect of Star Trek, right? Just on the kinds of technologies that get developed in the West. It's interesting.
It is. And I wish China, you know, good luck, because it's all collective science. And I'm sure that on the agenda, the using FAST, you know, lots of Western scientists will get to use it as well.
Yeah, there's a lot. I mean, like, there's a lot of collaborations coming out of the FAST telescope. Like when you see papers based on FAST, in some cases, nobody from China worked on it, that it was all a Western collaboration, or not, in some cases it's a team of Chinese astronomers and Western astronomers, and other times it's all Chinese astronomers. So they have made FAST very available to researchers. You know, they've got a bunch of other telescopes and instruments that they've set up. They've got a new powerful solar observatory. They're developing their version of the Hubble Space Telescope, which is going to be flying in formation with the Chinese space station. And they're doing a lot of work in gravitational wave astronomy. So they have plans for a space-based gravitational wave detector as well as ground-based gravitational wave detectors. And they are in the process of building the largest steerable radio telescope in the world. So there's a lot of research in this coming out of China.
The gravitational wave thing is interesting because there is a phenomenon known as glitching in gravitational wave detectors. And there's a recent paper on it that they don't really know if it's even real or if it's some sort of instrument abnormality. Well, if you've got two gravitational wave detectors on different parts of the planet, then you might be able to pick up the same thing at both, detectors and figure out if this is actually astrophysical or if it's just some sort of instrument glitching in LIGO.
Yeah, yeah. Well, I mean, LIGO already is two separate observatories that are designed to do exactly this, that if one detects something happening and the other one doesn't, then it gets thrown out. You need confirmation on both observatories to detect it. But I hadn't read this paper.
Now, I saved the best for last because it is the instrument that's coming online that excites me the most, because it's just going to be an absolute data dump. And that is Vera Rubin.
Yeah.
And that sees first light this coming year, I think in late 2024.
Yeah.
What's the progress there?
Yeah, that's it. That's the progress. I mean, the progress is that we should see first light from the Vera Rubin telescope. So Vera Rubin is this 8.2 meter, like the big telescope class in Chile, with the largest camera that's ever been built. It's like 3 gigabyte camera, and it will take an image of the night sky every 15 seconds and then move on to the next spot beside it, take an image of the sky. And because it's this big telescope and it's built with adaptive optics, it's going to take really deep, really faint images of the sky, and then all of this data is going to be dumped out onto the internet. And its job is to find all of the things that the universe does when we weren't looking. So it's going to be looking for supernova detonations. It's going to be looking for asteroids moving through the field of view, new comets, Planet 9, all of these things. And entirely new phenomena that we had no idea were going on out there in space. It's only by looking at the entire sky continuously, every 3 days, it will update its images of the night sky, that these things will be found. And I'll give you some examples, like Type 1a supernova, which are one of the most useful things that astronomers use to measure distance in the universe. It's how we discovered the presence of dark energy. It was found using, studying these Type 1a supernova, and over the 25 years that astronomers have been doing this analysis, they found about 1,500 of these Type 1a supernova. Vera Rubin, in its 10 years of operation, should find 1 million of them. Right? And other variable stars and other supernova, and like, who knows what it's going to find. There's like this class of asteroids that NASA has identified, the ones that are 140 meters and bigger. They found most of the kilometer-sized ones, but it's the ones that are down to 140 meters that are still dangerous at a, local level, the city killers. And Vera Rubin will find them all, like 90% of them. And so, again, you've just got this incredibly powerful tool that's coming online. And I love, they've changed the way they're going to be releasing this data. So with Vera Rubin, everything is just going to be public domain immediately. And they're going to have this, it has this pipeline where it identifies important events in pretty much real time and then alerts the astronomers. And so there will be this one feed that is highlights that Vera Rubin has found on its own. It'll be like, oh, I found a supernova. Oh, and I found this variable star over here. Oh, and I found this asteroid. And there's Planet 9. And then there will be this other data. All of the data will be getting dumped out. And then you'll be able to use the tools on Vera Rubin to do targeted searches and say things like, well, I wonder, I'm looking for this kind of a thing. And you'll be able to dig through the archive to find what you're looking for. And so it's like, in the olden days, you would get time on a telescope to analyze some target. And then you would get your telescope time with James Webb or whatever, and then you would analyze that target. But now we're shifting to this world where instead of getting time on a telescope, you just dig through the archive, because everything was looked at simultaneously. And there's this continuous observation of the night sky, which is just wonderful. So yeah, there is no telescope that I am more excited about than Vera Rubin.
I just wish we had a second one, an identical one in the northern. Yeah.
In the north? Yeah, I agree. Yeah. Yeah, there is no time domain astronomy telescope planned for the Northern Hemisphere yet.
Maybe China will do it.
Yet. I wouldn't be. I feel like China is planning one, but I don't know where they would put it. It's hard to keep up with everything that China's doing, and
it really is, and they're not always forthcoming.
They're not forthcoming. No, they are terrible at telling us what they're doing.
Yep.
Probably, secretive.
Secretive, but also the fact that they may be telling everybody internally in Chinese newspapers, but it doesn't translate over somehow, and things are missed.
Yeah. I mean, I do follow stuff back into Chinese sources as best I can, but it's a whole other sort of internet, and the way news moves around on the Chinese internet through Weibo and their various WeChat. It's a different creature, so it's really hard to find news in the same way without just being immersed in it all the time.
All right, Fraser, we're out of time. It's always a pleasure talking to you, and I'm really excited about the year to come, and I'm really happy with how 2023 turned out.
100%. This is going to be a great year.
Event Horizon and my channel are now available as a podcast on Apple Podcasts, Spotify, and YouTube memberships. Early ad-free episodes, bonus episodes, and sleep-focused content. Sign up now by clicking the links below to your platform of choice.